Hi everyone, myself Arun Raja, working as an assistant professor in the Department of Aeronautical Engineering for the past 11 years. Today we are going to see about the different non-destructive methods and its introduction. First and foremost, we need to know what is the definition about NDT. The use of non-invasive techniques to determine the integrity of the material or component or a structure are a measure of some characteristics of the object without damaging the things. That's what called as NDT. Or simply we can say that inspect or measure about the particular defects in the system without doing any harm to the system. Next is about uses of NDT methods. We can use the NDT methods to identify the flaw detection and evaluation, leak detection, location determination about the cracks, dimensional measurements, structure and microstructure characterization about the materials, estimation of mechanical and physical properties of the material, stress and strain about the measurements, material sorting and chemical composition about the material, and its determination can be done through the non-destructive methods. When it is used, it is going to assist you in the product development to screen or short incoming materials, to monitor, improve or control the manufacturing process over the product, to verify proper processing such as heat treatments, and to verify proper assembly which is done exactly in the position or not, and also in inspecting service damages. The most common NDT methods are displayed here. The first and foremost is visual inspection, liquid penetrance inspection, magnetic particle inspection, ultrasonic inspection, eddy current, and X-ray inspection. These are the 6 common used NDT methods for the materials. The first thing is visual inspection. It will be the most common inspection method used to find cracks or defects in different materials. The tools includes fiber scopes, borescopes, and magnifying glasses and mirror to detect the cracks or the defects present in the material. The portable video inspection with different magnifying glasses or different zoom levels will allow to see through the material. Robotic rollers may be used in some hazardous places and tight areas like ducts, reactors, and liquid penetrant inspection with high surface wetting characteristics is applied to the surface of the part and allowed to seep into the surface, breaking effects. The excess liquid is further removed from the surface part and the developer is applied to pull the trapped penetrant out of the defect and spread it on the surface where it can be easily seen. Visual inspection is the final step in the process. The penetrant used is often loaded with the fluorescent dye and inspection is done through UV to increase the test sensitivity. Magnetic particle inspection is another term. Here the part is magnetized and finely milled iron particles are coated on the dye pigment on the applied material to specimen. These particles are attracted to the magnetic flux linkage fields and will cluster to form an indication directly over the discontinuity. This indication can be usually detected under proper lighting conditions and we can see the defects present in the component. These are some of the indications we can see through that magnetic particle testing. Radiography. The radiation used in the radiography testing is higher energy version of the electromagnetic waves that we can see as a visible light. The radiation can come from X-ray generator or a radioactive source that you can see from the image itself. The X-ray generator puts some electron beams or light waves that can pass through the component. The part is placed between the radiation source and piece of film. The part will stop some of the radiation coming from the generator. The thicker and more dense area will stop more of the radiation. The film darkness will vary with the amount of radiation reaching the film through the test object. If the film is less exposure, then the thickness is okay. If it is more exposure, the thickness is going to be small. These are the images or the results that can be found through the radiographic uh, method of testing. There's another method called eddy current testing method, in which the electronic coil magnetic field is used to generate magnetic current field, but it can be used only in the conductive materials. It can't be used on the plastic materials which are not able to produce the eddy currents. Eddy current testing is particularly well suited for the detecting surface cracks, but can also used to make electrical conductivity and coating thickness measurements. Here a small surface probe is scanned over the part surface in an attempt to detect a crack. Ultrasonic inspection. High frequency sound waves are introduced into the material and they are reflected back from the surfaces or flaws. The reflected sound energy is displayed versus time, and the inspector can visualize a cross section of the specimen showing the depth of the features that will reflect sound. If the sound wave is having some echoes or the sound wave cannot reflect back, then we can identify there will be a defect in the system. These are the ultrasonic images can be produced by plotting signal strength or time of flight using computer controlled scanning system. The left side one is the grayscale image produced using the sound reflected from the surface of a coin, and the right one is the reflected image coming out from the system. The common application of NDT is on raw products following secondary processing like heat treatments, and in-service damage inspection where it is working with some other um, usage of materials. Thank you. Thank you so much.